Next example, very similar one. Find the phasor based on cosine. Find the phasor transform of a given trigonometric expression. Okay, we'll follow the exact same steps that we did in the example one. Okay, so we are going to begin with step one, which is to convert these to phasor form. So 5 angle 36.8 is the phasor for this guy. Okay, then the phasor for this guy is 10 angle negative 53.13 degrees. All of this is in amperes. Okay, now what we do is step number two. We are going to convert these into rectangular form. Why do we want to do that? Because we have an addition operation on our hands, and addition operation is better done in rectangular form. So here 5 angle 36.87 can be expressed as 5 cosine. Let me continue with the color scheme. 5 cosine 36.87 plus j 5 sine 36.87 plus the next thing is 10 cosine negative 53.13 plus j 10 sine negative 53.13. Okay, all of this is amperes. Now 5 cosine 36.87 degrees. Okay, if you plug it into your calculator, you'll see that this guy is 4 plus j 3. Okay, all of this guy is 3. Okay, similarly 10 cosine 53 negative 53.13 is really 6. Ask your calculator, it will tell you that j10 sine negative 53.3 is 8. Okay, so now the addition operation is pretty straightforward. Add the real parts and the imaginary parts separately. Okay, so what you will see is this guy is going to turn out to 10, 6 plus 4, 10 minus j 5. Okay, this is in the rectangular form. You want it to convert to phasor form. That's step number 3, right? Step number is to convert this polar form. Okay, how do you convert to polar form? Well, the value of r is square root of x squared plus y squared. Okay, and angle theta is arctan, you see, imaginary part over the real part. Let's be very, very careful for this. Okay, so this is going to turn out to be 11.18. Okay, and this is going to turn out to be negative 26.56. Okay, we have to be careful with the angle here. Let's pay attention. We want to be very, very careful. I'm going to write it like this. You see, I'm going to write the negative term for the imaginary part. When I'm looking at the imaginary part over the real part for arctan, okay, notice that the negative here applies to the imaginary part. Okay. On the other hand, if the real part was negative, if the real part was negative like that, I would have plugged in a negative here, okay, and not on the numerator. Mathematically, negative 5 over 10 is the same thing as 5 over negative 10. However, we have to be extremely careful when we are selecting the angle. Let me explain. Okay. For example, let's see, I have my Cartesian coordinate like so. Okay. Here is my real part. Here is my imaginary part. Where is this um, real part of 10 and imaginary part of negative 5 going to be? Okay. In this quadrant, real part is positive, imaginary part is positive. In the second quadrant, right here, the imaginary part is positive because it is above the origin, whereas the real part is negative because it is to the left of the origin. Similarly here, both the imaginary part and the real part are negative. And on this side, okay, right here, both the real part is positive, and the imaginary part is negative. Okay, because it is below the x-axis, the imaginary part, all of the values of y are negative. Okay, you see what I'm saying? It's a very delicate but important distinction that we have to note. Now, tangent inverse of negative 5, okay, and 10. 10 is the real part, negative 5. So your point really happens to be this guy, 10j negative 5, really happens to be in the third quadrant, in the fourth quadrant, right? Bottom right. Therefore, we have to be careful when we do this, okay? When we do this, we want to make sure that we report the angle in the fourth quadrant. So negative 26.56, okay? Or um, we could even add in the counterclockwise direction and then report it in the third quadrant. But the important thing that we want to understand is um, when we are reporting the angle, we want to make sure that it is in the correct quadrant. Okay, so angle 26.56 is correct in this case. We'll see another example where we have to add an additional 180 to make sure that it makes physical sense. But for now, um, we have at the um, arrived at the answer, which is 11.18 angle negative 26.56 degrees. We are asked to find out the phasor equivalent, and this guy is the answer.